All right. Welcome all to today's Passive House Alberta Building Better in Alberta webinar series. It is sponsored by the Alberta Eco Trust, and my name is Frank Crawford. I am the Education Committee Lead for Passive House Alberta. And today, Haitao Yu, who is the R&D Director for the Landmark Group of Companies and a member of the Technical Committee for the CHBA Net Zero Energy Home Labeling Program, we'll be talking all about Landmark's project to combine 100 net zero homes into a virtual power plant. First, I'd like to thank the Alberta Eco Trust for their ongoing support. It is very helpful in allowing Passive House Alberta to continue our work. As always, you can place your questions in the chat box and I will ask them at the end, or at the end, you can also unmute and ask them yourself. So now, please take it away, Haito.
Hello everyone. Good noon. So my name is Haitao. I work for Landmark Group. I'm the R&D director of the group. Let's go to here. I think I just want to have a brief introduction of the Landmark Group. We are mainly a production builder in Alberta. The company has 47 years of history and built over 20,000 homes across the province, mainly in Edmonton and Calgary. Our products range from the entry level kind of single family home with detached garage up to a four-story apartment buildings. So here is our net zero journey. Actually started over 10 years ago. We built our first net zero NG home in 2012, and then we built the first net zero show home in 2013 in Calgary, Cranston. And then in 2017, we built in Canada the first affordable net zero home, which the price on the market is below 400K. And then in 2020, we built the first net zero ready home community here in Edmonton, which consists of kind of 40 units. That project is supported by the supported by kind of emission reduction Alberta. Current up to date, we build over 40 net zero NG homes, 100 plus net zero NG ready homes. And also we have our kind of solar company, so we also installed over 300 of residential solar PV system on our new homes. Here is our why kind of net zero. For that, Frank asked me to introduce why we're doing net zero. I think for sure for net zero, the first kind of motivation is to deal with the climate change. So it's mainly come from sustainability kind of ability. So I just put out those. One is from CHBA Net Zero Home Labeling Program. So there are kind of value, the three values mainly for net zero home is also net zero home is kind of better home. It's also provide the additional value to the homeowner. So great comfort, healthier living, and also I already mentioned is kind of environmental kind of benefits. And also I put in another one I think is a really good kind of marketing a strategy from US because they also have they call it zero energy home. So they are the sales point will be there is the future of housing kind of today. So they have a really good kind of graphic to show what is the benefits of building net zero homes. So who are I just want to hear who are currently building net zero. So the CSBA net zero home labeling program started about 10 years ago. So the last year the CHBA net zero council just published a 10-year impact report. And then in the start from the pilot project with kind of 15 net zero homes registered. So in 2015, after 10 years, up to a couple days ago, the most kind of recent data shows is almost 2,800 homes registered for the labeling. They are in CHB Net Zero kind of website. They shows all the builders who and also the number of homes they net zero homes they build for the program. I just take a screenshot from the website, and then you show who have the most kind of net zero homes in Alberta. So the Avalan home the Avalan master builder in Calgary, they have over 190 kind of label, followed by us, Landmark Homes Edmonton. So far we are applied to 23 labels, and although we build more because a lot of homes we build, we kind of didn't apply for the CHBA kind of label because some of all those units are rental units. So the owner is the owner of the project. They are not bothered really to apply for the label. And also the third one is kind of judgment. And then the others will be much less than in terms of the number of the labeling. So yeah, just as why is so we just can consider the market. Is there really a market for kind of net zero? So for that is a real question. But that actually are in Edmonton market, Landmark and German are only two production builder who really offer kind of net zero options to the mainstream home buyers. For us, we have three kind of communities. We provide this option because in order to build net zero homes, there are some requirements to the lots and also to kind of electrical service to the lot. So we can, because of their kind of land developer, the limitation, the entire design. So it's not really feasible to build net zero homes in every kind of subdivision. So currently we provide those options in three subdivisions we are building, and the other production builder build it is kind of German built. So they have tiers of kind of energy kind of performance homes. They are kind of selling. You can go to their website, and then they have the cost associated to all those options. So you can see the net zero ready homes with 10 solar panels. The cost of the German provided is about kind of 40,000, 40K for kind of incremental cost. And also for the 490, that number, the charge, the pricing go up to 82K. So that lead to the first barrier to go to net zero is the cost. So yeah, I just use one example we are currently building is the Bradford. Uh, that is a two-story townhome with basement, about 1,500 square foot. That's in terms of size. The total energy consumption based HAT 2000 modeling is 46.5 gigajoule per year. And then in order to achieve net zero, for every unit, we installed a solar PV system. The size is kind of 11 kilowatt. And also, according to tiered code performance, we are kind of 66% better than a 2050 code. So it's a little bit shy to tier 5. It's pretty close because if you're familiar with that, the tier 5 is 70% better uh, than the zero, right? Tier zero. So that is kind of space heating. Because here is a passive passive house. So I just make a little bit kind of comparison. The space heating load is about 20 to 20 or 24 kilowatt hour per square meter. It's it, it's a higher than the passive house standard, but still pretty good. Is enough for us to put put a solar PV system on the main roof to achieve kind of net zero. The air tightness is we cap is 1.5. Our actual overall test is between 1.2 to 1.4. So here is the cost. If we look at that, it's a building envelope. It's cost about kind of 30K, and then door and windows and doors because our regular it's now the main all kind of major builders we all use triple pin, but for that, in order to get kind of better performance, we use the triple pin with too low E, and then add cost about $1,000, and kind of space heating go to cold climate air source heat pump, 205 ton outdoor units, and then because here in the harsh winter, the COP of the air source heat pump will really will low when the outdoor temperature below -30. So we add in our 7 kilowatt resistant backup kind of heater in. The total cost of the space heating system incremental cost is add another kind of $8,000. HRV a little bit high performance one, $500. So water heating is a big item because we need to get a higher COP for the hot water. So we use air source heat pump hybrid water tank. And then we are in 60-inch of drain water heat the recovery overall are, and then we already introduced for each unit it's a kind of 11 kilowatt solar PV system. We add kind of everything up. So for every unit, their kind of incremental cost will be around 53K. So for that is about kind of 10%, a little bit shy of 10% of the all kind of pricing. That is you can go to landmark website. So for that for all those houses, we sell is around 650 or on average 650K on that house, because for that is a little bit unit because they're in the Bradford, so the lot price are a little bit higher than the other subdivisions. So we can say the incremental cost of net zero is about 10% of the overall pricing. And then what is the payback if we only can consider the savings on the utilities? For every year we about save 3,200 kind of dollars on the utility. So the simple payback is kind of 16 and a half years. So for that, if we only consider kind of economic, there's I don't it's not very attractive, because for that is that's kind of simple payback. We didn't consider the value of the money on time. So and also for the homeowners, if the payback, the investment of the payback more than 10 years, I don't think normally the people will consider. So that is why also why the net zero homes in the mainstream kind of housing market is not that much, because that is a big barrier. The top barrier is the cost. It will add 10%, and then the people either they don't have the financial capacity to go that, or they would rather to pick other options rather than the energy efficiency. So another big consider is you can see that each year currently for the standard, because in Alberta the pricing of natural gas is really cheap. It's about now is less than $3 per gigajoule. So for that is also another barrier, because there's no payback to save them. So and also for another side is kind of neither ready. There's no virtually there's no payback, because you use more electricity to save most of kind of space heating and domestic hot water heating. All those is on the natural gas. So for that is also one of the reason here. It's very hard to sell the kind of nether ready. Do we have really a solution? I don't think the market can do much better, because it's you want to save energy, you need to have a higher kind of energy efficiency equipment, and you need to add insulation to the houses. In that case, everything occur the cost. So the only thing I think the only thing now is kind of in the future the highly energy efficient kind of building is homes. The mainly is depend on the policy side in order to overcome the cost issue. So for that is a slide I borrowed from just 2 weeks ago, I went to the CHBA and kind of annual conference in BC, and then that is the one slide. The technical research committee meeting they shared on the trend of the building code. So that is the kind of timeline. Currently, we are on the 2020 code. Alberta kind of just adopted, and then now the 2025 code is already finished. The public kind of review. It will be published by the end of kind of this year, and then the maximum adoption will be in 18 months, and then now the 2030 code cycle is already started, and then they put on what the NG tiers. Currently, most provinces is still in tier 1. And then that is, we have a very tight kind of schedule to meet the requirements to go to kind of 2030, go to energy tier 5. And then also in the 2025 code, it will kind of introduce the operational carbon into the building code. Probably in 2030 code, it will introduce the embodied carbon. You can see here is the 2020 code adoption by province. In Alberta, we just adopted last year. So that is a tier 1. We mainly still on tier 1 right now. And then Ontario and the BC, two kind of largest market in Canada, they are about 2 years ahead. So in BC, they step code 3 is pretty much the similar level of tier 3 in the national building code. And then in Ontario is about tier 2.5. So I think in Alberta, we have already here is a report published by Build Alberta. So currently we are in tier 1, and then we expect we will go to tier 2 late this year. And then Alberta hasn't decided when it go to tier 3, 4, and 5. But I think the goal is to achieve tier 5 by 2030. And also it's at least the cost impact of all those NG tiers. So we can see from tier 1 to tier 3, the kind of incremental cost is not really much to achieve that, because we can improve a little bit here and there. We can really get there, but start from tier 4, there are really some effort need to kind of put in, especially the building envelope and also air source heat pump. So for that start, we can see kind of significant kind of cost increase in order to achieve tier 4 and tier 5. I think mainly the energy performance of the new homes is mainly driven by the policy to overcome the barrier of the cost increase. Now the second barrier is in the electricity kind of infrastructure. If we look at the tier 1 house compared, for that is a slide I borrowed from also CHBA Net Zero Council meeting in 2023. their energy advisor, they just do the analysis for a typical house in Ontario, and then they kind of use the energy modeling to see what is the peak load of the house. So for the tier one house, you can see what is the annual energy consumption, and then the peak load actually incurred in the summer, because in order to do the fair comparison, it include the cooling load. So for that is the peak load is 4.76 kilowatt in summer. But go back to the tier 4 house. In the summer, the peak load a little bit lower because of the better kind of insulation is reduce the cooling load. But because we need to kind of electrify the home, so the air source heat pump and hot water heating now is all on the electricity. Although we can save the overall kind of energy, but the peak load in the winter are much higher. Now it's almost the double. It's more than double the peak load. Now in winter, the peak load is around 10 and 10.65 kilowatt, which means you need a larger kind of service size. So for that is most of our net zero homes, we are now have instead of 100 amp service, now we provide 200 amps service to the net zero home. We just consider if only in our block or in our subdivision, only a couple of them currently in the current situation, a couple of them kind of upgrade the electric panel from 100 amp to 200 amp. It doesn't matter. It's not really impact on the electricity infrastructure. But if a large adoption, all the new homes in one subdivision are net zero or net zero ready, and then it will be have a big impact on the grid of our kind of electrical supply. So, and also, all net zero homes, they have a solar PV system, pretty large solar PV system on the houses. So it also creates another problem to the grid. For that is, we call it a goose curve. So for that is the demand and the kind of supply for the California market because of the solar PV system, the government tax rebate and also incentive program. The solar PV kind of adoption penetration to the market is really high over there. So you can see over there from year to year, the demand really going down when during the summertime, when the sun is shining, and also the solar PV system cannot generate a lot of renewable energy. So have a big impact to the grid stability. So on one side, all the net zero homes during the winter, they need a higher peak. So that in that case, you need to add kind of supply to the entire grid. And on the other side, during the summer months, because of all the solar PV generation, renewable kind of generation, the demand will go down to the valley. So you have all those kind of capacity will not be used. So for that is those peak and valleys for the demand and the supply will create a lot of a problem for the kind of utility company like Apple. So for that is what the problem here. One of the solution is the we call it a virtual power plant. It means for all those net zero home solar PV systems, we need to add a battery in it and connect all those battery become a power plant. And then so that power plant will help to be controlled by kind of utility provider. So to trim the peak and also have the valley here. So for that is the project, our current project we are doing right now. Uh, that is at least all the partners for that project. We got funding from Emissions Reduction Alberta to have a larger project to have 100 net zero homes in Bradford for every net zero home. Uh, uh, 20 kilowatt hours solar coal battery kind of installed over there, and then all those 100 battery connect to one VPP platform. The thing is, we have some goals for this project. At least over there we have kind of technical kind of objectives. We want to kind of figure out how to integrate a VPP platform with kind of ethical terms kind of system. And also, we want to know how under Alberta's current regulatory environment, how to kind of operate the VPP and for sure the VPP costs money, and we want to build a kind of economic model to see who will kind of get benefits of the VPP and can share the cost. So the overall goal for this project is to develop and demonstrate a VPP solution for future large-scale implementation. So for that also for we Landmark as a builder, what we are really focused on, what is the benefits our home net zero homeowner can get. So mainly here, there are three major ones. One is for sure we will increase the solar power self consumption. Mainly is when the solar PV system generate the solar power. That solar power can charge the battery for the use kind of during the night. And also another thing is will provide the power security for all net zero home. There are some we call it a protected load. Will connect to a panel, connect to uh, uh, the battery. So that battery, when there is a blackout, and then the battery can kind of discharge to supply all those base load. So in that case, because now in Alberta we don't see much blackout, but now currently because of climate change, more and more these things happen. We can see in this year in Ontario, in Quebec, also in Atlantic provinces, we see a lot of kind of blackout uh, due to the extreme climate situations. So, but we think we believe in the future, because of all those extreme climate conditions will occur more often, even in Alberta. That will be a really big benefit for our homeowners. And the last one, because all the batteries will connect to the VPP, so the power can be aggregated to sell into the wholesale kind of market. We all know the wholesale market, the power is go up and down kind of dramatically. So the platform, the VPP platform will enable all those homeowners to benefit from those fluctuation of the wholesale market. That we currently we already have six of batteries online. For that is one I just pull out actually when I put together the slides. That is 1 week of the energy profile of net zero home with batteries. So you can see all those kind of orange part is the solar PV generation. Actually, for that is yesterday, so it's go back to a week. So we can see in the last 4 days, the solar PV generation very good. And then the last because of the raining days, so it's not that bad. But we still can see all over here how all those gray stuff is the energy consumption of the house, and then the green line is the level of the battery charge, the power charge in the battery. So you can see when kind of during the night the battery discharge to cover all the energy consumption, and then in the morning they start to charge again, and then go to the maximum 100% at about noon, and then they start the cycle kind of repeat every day. So if we just pick a good day, it's May kind of 22nd. I put it over there. You can see almost for the entire day, the house almost not use any electricity from the grid. It's the house, the unit is kind of independent. So it's a kind of 99% kind of independency. And then for the solar generation, it's much more than the kind of consumption. So it's a maximum self-consumption is at 22%, and then the others kind of 78% will was exported to the grid. And then even on the days not have much kind of generation for the data that day was raining. So in that there is a generation and the consumption, they are pretty much the same. So but for that day, and also there is a 97% independency. It means 97% of the electricity used on site are supplied by the solar kind of solar power. So for that you can see, even on the raining day, and then because of the battery, almost all the energy consumption on site is covered by the solar PV generated on site. So the other advantage to have all those systems is from the system we can get really good data. Actually, we can get minute by minute data, and so for that really help us to figure out what is the actual kind of peak load of all those units, because all those peak load we do the calculation. It's actually based on the national kind of electrical code, but that code is very updated, and that code is about the load in those code. The calculation is already kind of 20 years, 30 years old, the formula. So we want to see in this because we can get all the detailed the data on the energy consumption, on the kind of production, and with the battery, want to see whether we can develop kind of simulation model and then to see what is the actual peak load for each unit and then for a building or and then for a larger, for example, entire subdivision. And also for that is the area data. We can get also the area. We can see clearly the energy profile of the building. We can compare what is the actual production and consumption compared to the energy modeling, and then how the consumption and the production interact kind of each other, whether we can use the kind of battery to optimize uh, the energy profile and then can make the production and the consumption more balanced. So for that is a really a powerful tool for us to do a lot of research. That is why U of A our research team also join the project. They will collect all those data and then build a simulation model and then to do a what if analysis for some scenarios to help us to make informed the decision on the operation model and to quantify the possible potential benefits to all the kind of stakeholders of the VPP. And then here is the project timeline. The project actually started in January 2024. So everything is on schedule. Currently, we have already installed 8 integrated solar and plus battery systems. Now we are in the milestone 3. We already start the construction of 10 units, 10 new units in Bradford, and then all those will be equipped with the solar PV and the kind of battery system. So, and then by the end of the year, we hope we can install about another 20. So that, and then the entire project will, the end date will be in the mid of 2027 because we want to have for about 2 years of the data to do the research and then to kind of develop the operational and the kind of business model of the VPP. Okay, so that is all my presentation. And then now, if you have any questions, yeah, yeah. Now it's time to answer,
Yes.
to ask questions and answer questions. Yeah.
Excellent. Excellent. Thank you, Haito. So does anyone have any questions? Lots of interesting data. Obviously, that Landmark has been kind of leading the way to high performance homes for a long time, and good to see you already got a few batteries installed and starting to get some data from them. So anyone want to unmute and ask some questions? If not, I have one or two. Okay, I can get things started. A little more into the details. So do you have a separate emergency circuit electrical panel, or have you looked at using some of those newer smart electrical panels from like Levelton or something like that?
Actually, we didn't use the smart panels. Actually, for our hours, for our the, all those kind of loads, this there we call it a protected load. We have a sub panel.
Okay.
All those loads connect to the sub panel and then connect to the battery. So in case of blackout, The solar PV system, battery and sub panel become a kind of small off
Off grid
grid
or microgrid or
system.
islanded. Yep.
Yeah, microgrid island. Yeah, that is how it kind of did that.
Okay. That just seems the most cost effective at this point, but you might look at other options going forwards, but that's the best so
Yeah,
far.
actually we at the beginning at the design stage we look at all those smart panels. Yeah, they are really expensive.
Yep. Yes. Yeah,
Yeah, yeah, they
we've done
are.
some similar research, and yes, they get pretty expensive pretty quick. Uh, anyone else? I guess in the looking to the end goal, is the goal that people buy the battery or rent the battery? Do they get full access to kind of the the higher rates that they sell it, or is that kind of how it pays off the rental of the battery? Like, have you thought out the business model or not yet?
Yeah, actually, we hasn't decided yet. That is one of the goal of the one of the objectives of the project because currently we don't really know who will benefit from the VPP and then how much. So I think for that is one of the goals. We want to kind of have our build a kind of simulation model and then try some scenarios. And then I think basically the cash will fill in for improve um, the on-site use of electricity. For that is one. It's a the owner will kind of benefit that because you consider currently the fees charged to the electricity almost the same of the value of the power. So for that, they kind of double it. And then another one is really we trigger how to use the VPP to sell on the wholesale market. Because we all know that in the wholesale market, the price fluctuates kind of significantly, especially current because of all those renewable energy on the grid. We even in Alberta here, we see sometimes the wholesale market, the electricity is zero. The price is zero or even minus. And so it means they pay for the people to use electricity. On the other hand, on the really peak demand, and then the electric prices go to kind of to the ceiling. So it's a lot of fluctuation over there. But currently, our natural home they can run because they pay the flat fee for the month, or even the fixed price for electricity. But we hope in this project we can see whether we can aggregate all the solid all the kind of batteries and then can become a player in the wholesale market.
Yeah, yeah. The potential is definitely there, but yes, this is a great example of using grant funds to figure out exactly what the
Yeah.
results can be based on
Yeah.
data, not guessing.
Yeah.
Question from Martin. So I think this is going back to just your kind of the initial slides about just higher performance and net zero homes. What are you seeing the interest in high performance net zero homes in Alberta? Is there any hesitancy regarding the technology, or what do you see your big selling features or your big drawbacks? You kind of talked a bit about that, but maybe go into a bit more different detail.
Yeah, I think mainly now currently everybody wants it, but the only thing is the cost, right? There's basically the payback is really, I think, yeah, put in here, the payback is really long. Normally, for the solar PV system, for that is our experience. Because we do, if the payback is kind of less than 10 years, like between the sweet spot is between 5 to 7 years and then people will jump on it. They would like to do the investment. But if longer than that, people lost their interest. They rather they put the money on the other side. So we hope with the tiered code in the next 3 or 4 years, and then because the the kind of baseline is going up, right? So it will be more feasible for the high kind of performance homes to be more competitive on the market. And another thing is really rely on because if in terms only the kind of economics, it's mainly based on other mailing stuff. For example, whether we can put it into the market, right? But that is there's because currently no, it's very hard to for the banks, they consider kind of net zero home, they will give uh, the high mortgage quota, right? So they know, they currently know. So some people they would like to put them into the market, but they can't. Um, yeah, yeah. I think there's still a lot of things we need to do, and then in order to make the high performance home more affordable for the mainstream home buyers.
Yeah, yeah, definitely. As codes require the building the bar to come up, then the differential goes down,
Yeah,
and also hopefully as more people more people buy the high performance equipment, the cost of the equipment can come down as well.
yeah, can
But yeah,
come down.
we're
Yeah,
still in the
yeah,
we're past the trial phase. We're into the early adopters and trying to get more of the mass
yeah,
adopters.
yeah.
Um, and I guess are you seeing to the type of houses? Are you seeing it the cost premium for net zero is less in attached townhouses versus single family because you have less exterior wall, or does that make much of a difference, the typology?
Yeah, I think so. Because it's a really when I see the market, they both have accounts for the single families. In the past, majority of our net zero market sell homes are single family because normally the single family home buyers they have a higher financial kind of capacity to pay for the extra. So the and also for the multi-family, there's a dilemma out there because if you're doing kind of net zero, you need to do all the homes in one block, go to net zero, and then there's not enough market it will be take a really long time to sell for example, 5 net zero homes or even 7 net zero homes in a town home block. So mainly in the past, although the cost per unit will be lower, but it's hard to sell
Yeah.
in a market. So in the past we didn't, but we did a couple of net zero and net zero ready communities project on the purpose rental projects. Also, one is the government kind of policy because you get CMHC loan if you have get a higher score when you have a higher kind of NG performance. So some are kind of the developer or rental project owner, they prefer to get score from the NG kind of efficiency rather than lower the rents. So yeah, there's a trade-off over there. Yeah.
Yeah. All right. Two follow-up questions kind of on pricing. So you're talking kind of net zero on-site energy. We're obviously in a passive house. So what we've been seeing is that in different locations, the cost premium for passive house can get down to kind of the 5% range, which I guess actually kind of feeds into if you then add solar panels to that passive house performance package, you're getting kind of that 10%. Um, and I guess the question is, the Build Alberta had that number where they said it's going to be 70%. Do you have a lot of confidence in that build number, or do you think they're a bit maybe being overly cautious and making it bigger than it needs to be when your numbers are seeing that to kind of get higher performance is kind of 25,000, and to add on the solar panels, which is basically just buying electricity, is the other 25,000. So
Yeah, I think they are Build Alberta uh, data in this table for the tier 1 to 3. They are pretty accurate because there is we all know how to achieve there. But for the tier 4, a little bit higher than our experience because they got their data from one of kind of builders, right? So it's really depend on because our air source heat pump, it depend on where you buy it, how to optimize kind of the design. And then for the tier 5, it's huge. I don't think it's that high because that number even higher than us with the 490 price. So with the solar PV system. So I don't think because tier 5 and also I think in the future probably we don't really need to go to tier 5 to that high because there's a study in the CSBA 90 kind of labeling program. We consider only with our about 3,000 of 9090 ready homes labeled by the program, only less than 10% go as high as tier 5, above tier 5. So now I think the sweet spot will be tier 4.5 or something like that. So I think now we are working with uh, the uh, the work group, kind of working group of the next round of the code. We kind of lobbying to lower the requirement of tier 5 to about 55 or kind of 60% uh, better than tier 1. But that is what we think is kind of appreciate yeah, proper kind of level to achieve the goal. Yeah.
yeah, I agree. It's all about optimization. So if you
Yeah.
ask someone that has done it before, the number's higher. If you ask someone that hasn't done it before, the numbers. So if you
Yeah.
ask someone who knows what they're doing, the number's lower. If they haven't done it before, the number is higher.
Yeah. Yeah. That's
Yeah,
it.
and we kind of agree that once we some of the research we've doing is once you get to tier 5, some of those just base electrical loads, there is nothing left besides the base electrical load. So it's very hard to get those tier 5 numbers on smaller units because of those base electrical loads, and like domestic hot water kind of take up so much that you can't save any more on the rest. So yeah, the tier 4 I think is very achievable. Getting all the way to tier 5, depending on the
Yeah.
size, is
Yeah.
more difficult. It's very similar to what you're seeing. So yeah, so we're coming up to the end. So thank you very much, Hato. Obviously, we'll probably have to have you back in 2 years, or make sure we watch the
Yeah.
Alberta emissions reduction webinar for when you get some data from this excellent project. So thank you very
Okay.
much.
Okay. Thanks. Okay. Take care then. Bye.